first honor, highest in rank, or the valedictorian in your class. Okay, congratulations. We're very, very proud of you. Okay, going back to this problem, linear momentum again. Okay, problem number 2. How much force exerted, okay, by a hose, wow, that expels water at 15 kilogram per second at a speed of 30 meter per second. This is very practical in the, workplace, in the process. Okay, but the only difference is you don't compute, but you do it already. You get the point? You do these things in the actual, but you aren't particular how many force you exerted. But here, we are very, very particular what force exerted. Okay? But actually, we did this several times in the workplace already. So there's a hose like this, a hose like this, a fire hose or potable water hose or any hose, right? So like this. And this is the nozzle, something like that. And the water will expel here. Expel in English meaning release. The definition of expel, release. Okay. There another term also, produce. Okay. And then rejected. Okay. And then what else? Delivers. Okay. Delivers. And then what else? It's gonna be like that only. Expel, release, produce, rejected, delivers. Rejected from the inside of the hose. When you reject, meaning the water will remove. Or remove also, right? Remove. Ganon. So these terms are just the same. But they use the expels in which not very common to everybody. I think so. Okay, but this is already common, but still not common to everybody. Okay, so take note the English grammar and the vocabulary being used in the paragraph or in a sentence so that we can analyze very well. Okay, to tell you honestly, this is my advantage when I take up the board examination, the English. Okay, because it's a gift of God that you can interpret well the paragraph, the sentence, like this, so that you can solve properly. Okay, you get the point? Okay, now like that. So if you have a gift from God, you are good in English, then the only thing you have to do is to practice solving math and then study hard. Okay, bingo, because you can understand, you can analyze well. Okay, so it's gonna be like that. So how much force, meaning we are looking for force, okay. Exerted is also the same as applied. Okay? Force applied. Or let's say delivered. Okay? Or inputted. Okay, this exerted. Okay, ha? So, by a hose. So, this is our hose. H-O-S-E. Okay? The water will be removed, will be expelled. Okay? And then, at 15 kilogram per second. Now we need to identify what is 15 kilogram per second. So what is this? Is this a density? This is a solubility? This is a flow rate? Or this is a velocity? Whatever. Okay, so 15 kilogram per second. So the mass is in the numerator. This is going to be mass flow rate. Okay, because there's time in the denominator. Okay, always inculcate in your brain cells or accumulate in your brain cells if there is a rate, the time will be in the denominator. Could it be a second, a minute, an hour, a day, a year, whatever. Okay? So, kilogram per second. So, rate na siya. Rate. Then the mass is in the numerator. So, mass flow rate. Why flow? Because the water will flow. Okay? So it's gonna be like the interpretation will be like this. So mass in the numerator, okay, and rate in the denominator. Since the water is flow, you're gonna call that as mass flow rate. Okay, you get the point. Now here we have at a speed of 30 meter per second. Take note, guys. The term is only using speed, meaning it doesn't involve direction. Only the magnitude. It's not particular in the orientation where this water will go. Could be the north, south, east, west, left, right, up, down. So we are not concerned with the direction. As long as there is a speed. That's why the speed term is used, not a velocity. You get the point? Because speed is only, scalar. You need to consider the direction, only the magnitude. But for the vector quantity, we need to consider the direction, the orientation, where the flow of water will be. Okay, but we are not talking with the velocity here. Speed only. Okay, like that. Now, force is equals to mass times acceleration. Okay. Tanawa mga palangga. Force is equals to mass times acceleration. We don't have mass in the problem, and we don't have also acceleration in the problem. So, problem. This is equation 1. Okay. Now, think another problem that it involves the momentum. Okay, because whereas momentum is here. Okay, it's gonna be like, hala, lisod na siya sosyotero. What is tricky here is the momentum is not mentioned. Okay, see? How much force exerted by a hose that expels water at 15 kg per second at a speed 30 meter per second? You need to analyze, guys, that momentum involves speed or velocity. So in that alone, you will think momentum. Because speed and velocity considers in the equation of the momentum. Bahala wala siya dimension. Even though it's not mentioned literally in the paragraph, since you know that the equation of the momentum involves velocity and speed, consider that also in your brain cells. Okay, something like this. Equation number 2. So velocity equals to mass. Okay, momentum, mass, the change in velocity. Ganon. Okay, hala sa shooter, wala sa kuy mass. Okay, but you have the velocity, right? 30. Oh, it's okay. Right. Now, kaning 15 km per second is the mass flow rate. Okay, MFR. Okay, mass flow rate. We have also VFR, volumetric flow rate. Okay, the mass flow rate can either be kilogram per second, gram per second, pound per second. Okay, then kilogram per minute, blah blah blah, gram per minute, like that. Volumetric is gonna be liter, meaning volume, liter per second. Okay, cubic meter per second, cubic meter per minute, something like that. As long as your numerator is in volume. Okay, because volumetric flow rate. Okay, but these all are flow rates. You get the point? Flow rates composed of mass flow rate and volumetric flow rate. Okay, if it will be in enumeration in the question, what are the two types of flow rates? Your answer will be mass flow rate and volumetric flow rate. Ganon. That's in case if the question in the future is enumeration or list. Okay? You have to be smart enough. Something like that. Okay? You get the point, mga palangga ang hita. Okay. Now, since I don't have the mass, but since I have mass flow rate, you get the point? So, momentum is equals to mass flow rate. Kani siya, 15 kilogram. Though this is only a mass, you should also put that there as is. 15 kilogram per second times the velocity of 30 meter per second. Okay. Like that. Ayaw kahadlok, guys, na ni-deviate ka gamay sa imong equation. You get the point? Because this mass, guys, I'll teach you about science. The mass and the volume, you still have to substitute that if it is really a flow rate. Dito na siya magdaog. It will be, what do you call this in English? It will be a final battle cry. How could I say this? That would be in the final destination that it will be getting the correct analysis. Don't be afraid. For example, I say, force is equals to mass times acceleration. And then you don't have the mass, and you have the mass flow rate. Just substitute that also. Try that. Maybe the unit will become the Newton, like that. Don't be afraid. Try first. Okay? Others also also, which is the majority, try to multiply, try to subtract, try to divide, and then if there is in the choices, you will get the correct answer. Especially if you don't know really the formula. You'll just use the different mathematical operations, and then the result, you will find that in the choices. As long as the unit will be equivalent. Calculate the force of blah 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 so and so. And then you don't know the formula because if you use the formula, you will not get the same answer. Okay, something like that. So you need to try, okay, something like that. So here, see, mass flow rate. Since this is a mass, it's okay lang yapon siya because it involves mass. Okay, 15 times 30, pila mga palangga kong hitad. I will show you the magic, ha? Mag-magic ta. Charot. So 15 times 30. Okay, ganon mga palangga kong hitad. 15 times 30 is equals to 450. Okay, 450. Take note for the unit. Kilogram, meter, second square. Because second term seconds is second square. So kilogram, meter, second square. And this is the unit of Newton. Right? So this will become force. Take note. The momentum will become force. How magic the science really is, right? Your momentum will become a force if you'll be given a mass flow rate. Okay, see, some things like this also. Because we don't introduce this kind of formula, momentum is equals to mass flow rate times, the velocity or the speed. We don't have this formula in science. But we need to open up our mind to, to calibrate where does our brain cells ends. We need to say, we need to be, atong tukiun ba until such madrain atong brain cells. Something like that. To sharpen our brain cells. Meaning, we never surrender so that we can get the answer. Okay, you get the point. No retreat, no surrender. Something like that. You have to try, you have to maximize all the formulas, derive, like that, blah, 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 so and so. See in here, the momentum will become the force. How come? Right? There's a magic, right? Because momentum is, of course, is not the same. But in here, your momentum and force will be the same because you have the mass flow rate. So ano na lang, in-immerse mo dayon na, hala, if we have a mass flow rate, even though the force is equal to momentum. Ano dayon? So, by the time you will solve a problem like this, so imo na yung so, okay? Force is equals to mass flow rate times the velocity. Ganon. So, kaya equal naman imong force and imong momentum. Okay? Ganon. Guys, this is not only the case. A lot pa siya. In which you will try to multiply, it will have an answer to be a force, but your formula you use is not force. Okay, this is the magic of engineering, or this is the magic of math sometimes. That sometimes you cannot understand why you have a formula like that, and then it will yield the same answer with another quantities. You get the point? Another example also, diba? Weight is equals to mass times acceleration to gravity. Force is equals to mass times acceleration due to gravity, right? So, ang force o ang weight ma-equal siya if due to the gravity, something like that, okay? If it is downward motion. Because force can never be a mass. Since it become a weight downward, so the force and the weight is just equal. For example, Junjun have now 65 kilogram. Calculate the force of Junjun. Imagine, that's only a basic question right now. I'm standing. So Tero is standing in the floor with a mass of 65 kilogram. Calculate the force so Tero exerted on the tiles. So I can compute immediately. Okay? Mass na po, 65 kilogram, then 9.81 acceleration to gravity. Bingo, I can solve the answer. I can determine my force. But this is not common because you will always use the weight. You get the point? In our discussion, in our classroom instruction, we will use the weight to compute for that. And then this is now analysis. That the force and weight is just equal. Okay? Like that, due to the acceleration of gravity. Something like that. You get the point? So, even though there is only one given, bingo na yun. So, I kahadlok. Don't be afraid if it is only one given because there's standard acceleration due to gravity. Something like that. Okay? Diba? Ganon. Okay? For example, Lenny Robredo stand on a stage. And Lenny Robredo weighs 65 pounds. How much force Lenny Robredo exerted on the stage? Oh, you can compute the force Lenny Robredo exerted on the stage because we have acceleration due to the gravity downward, which is 9.81 meter per second squared. If you know the weight and mass of Lenny Robredo, then you can compute the force of Lenny Robredo. Diba? You can apply that in the actual scenario, just like this. Okay? So, practical application of the theory. Any questions so far for this, Actually, this is not really the solid momentum. Oh, what I mean solid momentum? Meaning this is not really the the accurate momentum topic because the accurate momentum topic atong tumana siya. M1 V1 is equals to M2 V2. M1 plus M1 V1 plus M2 V2 is equals to M1, okay, M1 M2 times final velocity. Oh, ganon. Okay, we have the elastic momentum and we have the elastic momentum. Applicable in the soccer ball, football, basketball, and then billiard. As long as there are ball. So it involves momentum application in physics, ha? So ano na siyang application? For example, Junjun, gano'n dito. Junjun talaga. Kick the ball, something like that. Okay, ganon. So with the velocity of blah 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 and so. Calculate the momentum of Junjun exerted on the ball. Ganon. Okay ba? So it's very special. Okay. Any questions so far for this? Nothing? Okay. Sorry. If you like this video, you can comment down below in the comment section, and you can subscribe to my channel if you want, and I'll be happy for that. And you can also click the notification bell for some news updates. I am a singer journal voice. Bye bye, God bless everybody. Okay. Di ba mga palangga? Di ba sa'yo lang siya? Di ba sa'yo siya no? May nga na mga breaks lang guys, mga